Hi guys, I have a serious question for you. If our school lunch is $1.20, how much will it cost for the entire week? Before we attempt to answer this question, I first need to give you some background information by presenting this lesson on tables and functions. With tables and functions, you will understand that variables can be used to represent two quantities in a real-world problem that change in relationship to one another. At the end of this lesson, you will be able to use variables to represent two quantities in real-world problems that change in relationship to one another. Did you know that many everyday occurrences involve pairs of quantities that are matched with each other by some rule of correspondence? This is known as a relationship. A relationship consists of two ordered pairs. We learned from a previous lesson that ordered pairs are represented by using X and Y. Relationships can just about be anything. Some examples include the number of hours worked matched with the paycheck, hours, pay. Another example is the time of day is matched with the temperature, time, temperature. Now within a relationship in an ordered pair, there is an input and an output. The input is the value substituted into an expression or a function. The output is the resulting value of that same expression or function. The input is the controlling variable. Another name for the input is the independent variable, because its value determines the value of the output. The output is also known as the dependent variable because its value depends on the value of the input. This tree map better explains one special type of relationship, which is also known as a function. F-U. One last thing before we move ahead. The input, when referring to the coordinates, can be known as the x value, and the output can be referred to as the y value. Now that we have a better understanding of relationships and functions as it pertains to dependent and independent variables, let's see if we can answer that question. If our school lunch costs 120 cents, that is $1.20 per day, how much money will I need in order to buy lunch for the entire week? Well, let's start by setting up our equation. We know that $1.20 represents the constant, which is the price of the lunch. X equals the number of days, which is the independent variable or the input. Y is equal to the money that is needed, and this is referred to as the dependent variable, aka output. We can set up the problem as such. Output equals $1.20 times input, or Y equals $1.20 times X. In our problem, X is represented by 5, which is the number of days, 5 days. So in solving this problem, to figure out y, which is the total cost, all we would need to do is simply multiply $1.20 times 5, which would give us the total of $6. We can actually take it a step further and figure out the total cost or the money needed for a different number of days, just by simply creating a table. We've already figured out when X is 5 days, Y is $6. But when X is 4 days, Y is not $6. It would simply be $1.20 times 4. Why don't you take a moment and do this problem yourself? You can do this by simply pausing for a moment while you work out the problem. 4 times 120, which is a total of $4.80. And then you can figure out how much Y would be. The output would be, for 1 day, we know is 120. For 2 days, take a moment and try and figure out how much would the total cost be for 2 and 3 days. Once again, you can place me on pause while you figure this out. $2.40. For 3 days, it would be $3.60. And there you have it. We were able to answer our original question, which was figuring out how much the total cost of our lunch would be for the entire week if the lunch was originally $1.20. And then show variables to represent two quantities in real-world problems that change in relationship to one another, and write an equation to express one quantity, which is thought of as the dependent variable, and in terms of the other quantity, which is thought of as the independent variable.